And welcome back to Basis and Practice in Programming. We are going to continue in this lecture talking about pointers, which we already covered in last lecture. So we saw last lecture that pointers are just a kind of variable which point to another variable. So that means this pointer will be used to access another variable in the computer memory using indirect way, using something we call it dereferencing in pointers. So in this lecture we are going to talk about more uses of pointer and why exactly do we need pointers, why we are learning pointers. So last time we learned what is pointer, and today we are going to see why do we use pointer, or where we exactly use pointers. Okay, so let's start the lecture of this time. So let's see here. Last time I would like to remind you with what we have done last time. So last time we said we can create pointers like, for example, if we have integer a, and this one, or okay, let's say this one is variable 1, and this one is equal 30 or 20, and then there is another variable 2, okay, and this variable also equal, like, for example, 30, okay. And now we can create pointers for both of these variables. So for example, we can create integer, and then we say, okay, pointer of var1, this pointer for variable 1, and this one will point to the address of variable 1. Okay, it's very simple. So here we are creating the pointer, and also we said that the pointer is pointing to variable 1. Okay, now if you would like to print you can use a print to see what is this pointer, where exactly this pointer is pointing. That means I can see the address where is this pointer is pointing, or we can see the value of the variable the pointer is pointing to. Okay, so if the variable here, so let's see here, so there is a computer memory, okay, and variable 1, okay, this is variable 1 has some value 20 here, and then now we created a pointer, and we call this one ptr var1, okay, and this pointer contains the address of variable 1. You know, every variable is located in some location in the memory. That means it has address. For example, 32722. For example, this is the address where is this value exist in the memory. Okay, so that address of variable 1 will be here. So this one will be the content of pointer variable 1. It will be 32722. Okay, so this is the address of variable 1. Now if you want to see what is in the contents of this address, you need to use something we call it dereferencing. So the dereferencing means I will put star and then ptr and then variable 1. So this one we call it dereferencing. That means I want to see the contents of where is this pointer pointing to. Okay, so this is something like let's see here, something like this one. So I say printf, and then now here I will say, for example, the address of variable 1 equal, for example, and then I will put here modulo p, and this one all we studied last time, so I will put here ptr. Okay, so ptr variable, this one, this is the address of variable 1. Okay, and then after that, and value of variable 1 this is 1 equal, and then modulo d, because it's a digit. Okay, and this one will be what, how we can access using the pointer, access the value of variable 1. We access using star, okay, and then ptr variable 1. Okay, so this is very simple. Okay, So this is how, okay, let me do this one multiple lines so you can see what I'm doing here. Okay, so let's run. Okay, so you see here the address of variable 1 is this one, okay, and then the value of variable 1 is 20, exactly as we are expecting. So this is what we have learned last time, and today we are going to continue talking about the pointers. So I would like to start by talking about the arithmetic of the pointers. So for example, if we have a like pointer like this one, and then we create two consecutive variables. So I create character A and character B. In this case, when I am pointing, so you will see here this consecutive two characters. Now after that, pointer P is pointing to address A. How about if I did some arithmetic and I say pointer P will be added 1. I add 1 to the P. As you know, P is containing address. So when I'm increasing the address by 1, what I'm doing here? I'm increasing based on the pointer type. So if the pointer type is character, that means character is just 1 byte, that means I will increase in the address 1 byte. But in the other case, so for example here, you have pointer integer, and then you have A and B, and P is pointing to A. Then when you increase the address of P, it will increase the size of the data type of the pointer. So the data type of the pointer is 4 bytes. That means the address will increase 4 bytes, okay? So increasing 1, that means increase 1 integer. Increase 1, that means go to the next integer. And the next integer is B. So let's see this one together. So let's see this arithmetic together. It will be more clear for us. So here, if I say, for example, this is point to variable 1 and its type integer. And then after that, I will say here, for example, in a very simple way, I will say this one equal the old value of the pointer plus 1. That means I'm increasing the pointer by 1. In this case, I am going to the next integer inside the memory. Next integer. Why? Because the type is size integer. That means go to the next integer. This one does not mean increase the address by 1. No, it's mean go to the next integer. The next integer will be exist after 4 bytes in the memory. So let's see this one together. Okay, when I run this one, you will see here, it's going, so before it was, okay, so let me just print this one before and after so you can see exactly what happened. Okay, so here's before the addition and then after the addition. Okay, so let's run this one again one more time. Okay, so before, if you see here, before the address was 64, so it ends by 64, and then now after that the address became 68. Why it's increased 4 bytes? Because the integer size of the pointer is type integer, so the address will jump 4 bytes one shot. So it will jump in the memory address 4 bytes, okay? And now it will go the value, now the pointer now is pointing to a new location in the memory. A new location in the memory, so in this case that location contains some garbage, for example, okay? So this is contains some garbage. So this is exactly, this situation is like this. You will have, let's draw here. So you have a memory, the computer memory, and then you have now here variable 1, okay, variable 1, and then now you have ptr under the var1, and this one point to variable 1. That means it's pointing to this address, okay? It's pointing to this address. But now after that, when you say ptr plus 1, that means ptr underscore var1 plus maybe, like increase it 1. Increase it 1. In this case, it will jump and point to the next 4 bytes. That means it will point to something here after the first integer, after this one, okay? So it will point to the next integer. The next integer exists in the next 4 bytes, okay, in this area. So this is why, and in this area, if I say print the value of the pointer, where is the pointer is pointing, print the value, this area is garbage, contains some garbage from the memory. So in this case, it will just print garbage in the memory, okay? So this is how you can do the arithmetic of the pointer. Okay, so hopefully this one is clear. Now let's go to the this one. So the one important thing about here, as you see, because this is the pointer is character, it will increase just 1 byte, which is the size of the character. But in the case of the pointer is integer, the size of the integer will be 4 bytes. That means the address of the value of the pointer will jump 4 bytes. Mean the value will increase 4 bytes more, okay? So usually pointer arithmetics are very dangerous, okay? So you have to be careful when you are changing, you do some arithmetic on the pointers. You need to be careful. And usually we don't put this arithmetic for variables. We do this arithmetic if this pointer is pointing to some structure like array. If this one is pointing, the pointer is pointing to array, as we will see later, in this case, this arithmetic makes sense. But when the pointer is pointing to just a single variable, these arithmetic are bad to choose or bad to use, okay? Now let's go to the next thing, how to make the pointer not allowed to change the address. You are not allowed the pointer to change, jump from one address to another address. So for example, if you define the pointer, if you say for example C and D, those are variable, and then you make a character pointer, and this character pointer point to C. You don't want this pointer to change later to another address. So if you want that, you need to add this word constant here. So you add constant here. So after between the pointer and the asterisk here, or the star, you will put constant. That means this pointer address will never change. So it's all the time will point to C, okay? So in this case, if you try later to change the address of the pointer to a new address, it will tell you error. And let's see this one together. So for example, if I go here and I say this one is a constant, okay, and this one is pointing to variable 1, and then later I try to change the variable. So okay, here I say variable is increasing the address. I'm changing the address here. It will tell me error. Even if I say it's pointing to a new variable, okay, it's pointing to a new variable, it will tell me no, you are not allowed to point to a new variable. So this is how you can make the pointer point to a specific address or a specific variable and never change the pointer from this address, okay? The second type of the pointer is to make the pointer address change, but the value is not change, okay? So it points to somewhere or any address you want, but it will not change later. So this one, if you make the constant before the character, before the data type, okay? So if you don't want the data type to change or the data to change, you will make the constant before. So for example, I want the variable to change to a new variable like variable 2, okay? But later you don't want, for example, if I do like this, for example, after that, I will say here, for example, if I run this software like this, let's run this one before we go, it will tell me, look here, the first time, the pointer was pointing to this address, and this is the address of variable 1. And the value of variable 1 was 20, okay? And then next, after I change the variable to variable 2, now you have different address. This is the address of variable 2, okay? And then now the value of the pointer will be 30, okay? Which is the value of variable 2. Okay, if I want here to change the value of variable 2, how I can do this one? I will just say star PTR, okay, this is the PTR, equal, for example, 50. In this case, I am changing the value of where this pointer is pointing. So I'm changing this one from 30 to 50. So, okay, so in this case, let's see this one. you will see, here's it, 50, okay? The new value of variable 2 became 50, okay? So you change the value of where is this pointer pointing. If you don't want this one to run, you don't want to change the value, so you want the variable to change anywhere, so you can, the pointer can point to variable 2, the pointer can point to variable 1, but never execute this one. Never change the value of where the pointer is pointing to. So in this case, you will put constant here before the data type. So if you put constant here, in this case, it will tell you you cannot change the value of where this pointer is pointing, okay? So this is the meaning of the constant here. So this one means don't change the value, don't change these values, okay? So if you put the constant before the data type. How about if I put it here and put it here? So in this case, this one is not allowed, change the pointer address, and this one, change the pointer pointing value, is not allowed. Both of them will not be allowed. So this is very important to remember, okay? This constant here and constant. So here mean no change for the address of the pointer. Here, no change the value where is the pointer point to, okay? So this is, you have to remember every time about this constant for the pointer, okay? Hopefully this one is clear. Now let's go to another thing. Another thing for the pointer, I can make the pointer point to null. Point to null means point for nothing, okay? And then later I can make it point to something, okay? At the beginning, when I define the pointer, I say I don't know where this pointer will point to, so it point to null. Then later I say, okay, this is point to A or point to B or point to C or whatever, okay? Now when your pointer is pointing to null, you cannot read the value of the pointer. What is the value? Value is null, nothing. So in this case, this value of the point, the value of where this pointer is pointing to is nothing. But can you know the address of the pointer? Yes. The address of the pointer will be just the first address in the memory, which will be 000000. Okay? So let's check this one together. So if we have here, copy this code. So here I'm copying, and let's see this one together. Okay, so here we go. So here I create a pointer, and this pointer will be point to null. From where this null come? From this library. Okay, so this is a null, and then I say if the pointer is not equal null, if it's not equal null, then tell me the value of the pointer. If you do this one without if statement, if you try like this and say just give me the value of the pointer. Okay, just give me the value of the pointer, and then just give me the address of the pointer. Okay, I don't care, just give me the value of the pointer, and let's run this one together. And you see there is error. Error, why? Because he told you you cannot see, this is error here, runtime error. The software run and then shut down. Why? Because he told you you cannot read the value of this pointer, because this pointer is pointing to nothing. So how you want to read, to print the value of nothing, okay? So this is why this one show error. And this is why I did here some if statement. Say, if the pointer is not equal null, if the pointer is not pointing to null, then give me the value of the pointer. But if it's equal null, don't give me the value of the pointer, okay? Also here I said, okay, this one is okay. I can put this one like this. I say, print what is the address of the pointer. I want to ask, print for me the address of the pointer. So let's see the address of the pointer here. The address of the pointer is 00000. This is the address of this null. So the null is the first memory location in your computer memory. Okay? So it's address 00000. And what is there, you are not allowed to see. You are not allowed to see what is there in the 0000. Okay? This is designed by your operating system or by Windows. Okay? So they don't allow you to see the contents of the address 0000. Okay? So now let's go back to, so usually null, we use it if we don't know where is this pointer will point. Later we can give it point for A or give point to B or whatever. Okay? Now another thing is to make the pointer is void. That means I don't know what this pointer, the data type of this pointer. So the pointer could be pointing to integer, could be pointing to character, could be pointing to float, could be pointing to anything, okay? Any data type. So in this case, you can make it void, and then later you can change the pointer type to character or change the pointer type to integer. So let's see this one together. So here I can say, for example, the pointer is void, okay, and this pointer is nothing. So here, so this is pointing for nothing, and then later, okay, later I say I have, for example, character a, and this one is equal, for example, value a, okay, and then I have integer b, and this one equal, for example, 30, okay, and then I have a float c equal, for example, 3.3, okay, so this is like this, okay, this is the three variable, and then later I decided, okay, IP will be pointing, so I would say, for example, IP will be pointing to a specific data type. So for example, I'll say put character. So you know, put character means print character on the screen. So I say put character, and this character will be the value of the pointer. So the value of the IP. But before I say the value of the IP, print this one in the screen, I want to say here, same like as you see here, I will say pointer P, okay, pointer IP will be pointing to the address of A, for example. It's pointing now to A, okay? So now if it's pointing to A, that means A is character. So I will change this one to a character, so casting. So I'll put here star character. So this is now pointer is character. Okay, so this is what, sorry, I should put this star here. This is mean pointer character. Okay. So now it's character. So give me the value of the pointer, but I make casting here. It's a character because before it was void. I don't know, but now it's character. So I will print, let's say, see if this one will print the value of the pointer. Oh yes, the value of the pointer will be A. Look here, A. Now let's go and change this one to integer. So how about I print integer? So I would say print F, and then I will print, for example, the digits, okay, modulo D, and I say here, okay, now IP is integer. It's integer, and then I will put this one, this guy here, P. So IP is pointing to B, and then I will say this is integer. Okay, it's now integer, and then give me the value of that pointer. So let's see what is the value now. Yes, it's 30. Okay, let's go another one. So I can do here, okay, let's do, and then later I change this one. IP is pointing to C. Okay, now C is a float, so I will say this one float. Okay, look here. So, and then because this one is a float, I will put this one a float. Okay, let's run and see if this one is working. You see, it's first 30 and then it's a float number. Okay, by the way, I can put this one just in a new line so you will not be confused, and this one in a new line. Okay, so it will be like this. So one time it was 30, and then next time it became float, and so on. So sometimes first it was pointing to integer, and then later it was pointing to float number. Okay, so you can change the pointer. This one is a dynamic pointer. So this pointer can point to anything you want, any data type. It can point to character, can point to integer, can point to float, can point to anything. Okay, so you can change this pointer over time when you are using this pointer. So sometimes we need this one, but this one also seems also dangerous because you are changing the data type of the pointer all the time. So maybe if there is a mistake when you are changing the data type, you could make wrong results. Okay, so in this case, you need to be careful when you are doing that. So for example, if you say here, this one by mistake, it's pointing to B, and then in here I say this one is character by mistake. Okay, I just say this is character, and then you run, there will be no error, but now this one is pointing to character. Okay, and this one, for example, I say this one is pointing to integer, and then run, and now you see there is a damage happen. Look here, it was it is pointing to float, but because I say it's integer, but it's not integer, it's pointing to float, it must be float. So the results are wrong, okay? Where is the 2.3 is gone. Why gone? Because it's wrong conversion. Wrong conversion. So this is very dangerous when you are using this kind of pointer or this general pointer. So usually we don't use this kind of thing. We say, okay, we want integer pointer. So from the beginning we say, okay, we have integer pointer. If we want to float pointer, from the beginning we create float pointer. Okay, so from the beginning, decide what is the data type of that pointer, so you will not have any problem later converting from one data type to another data type. Okay, so really dangerous to do this kind of thing. But if you are professional and you trust your programming, which for me, I don't recommend, but anyway, if you trust your program and you are conscious all the time when you are programming, in this case, it's fine to use this kind of way. Okay, so let's continue. Now, why do we need pointers? From the beginning, this question raised all the time. Okay, the pointer is pointing to the address of some variable. Why do we need that? So the question will be answered now. So now we will answer why do we need pointers. So here is a function. I create function here, set x and y. And then here in this function, I pass address or pointer. Pointer is address. Okay, I pass pointer and then I pass pointer here. So when you pass pointer, when you give here A, I say give the address of A. Give address of A and then give address of B. Then in this case, any change in the pointer value will be changed in what? In the original variable. In the original variable, okay? So let's see this one clear by the example here. So I will copy this code just for sake of time, okay? Okay, I will do this one by myself here, okay? So it's very simple. So let's say here, for example, I have a void and then I have set values, and then I will have here, for example, okay, and then here I will have like two variables, like for example integer a and then integer b, okay? And then here I do some math and operations on the two variables like a and b. For example, we do some operation like what? Like for example, we say a is equal a plus 15 minus b, for example. We do this operation. So the new value of a will be like this. And the new value of b will equal 30 times 5 divide, for example, divide 2, okay? This is the operation we have. For example, this is some math. Now, when we do this operation, does this one change? And now, let's go here. Let's delete this one. And then I have a, and let's define here some integer a, not like, for example, integer x and integer y. And this one will be, for example, 10, and this one will be 30. And then after that, I will call this function set value. So I will call set value function. So let's say set value function, and then I will say here, pass x and pass y, okay? Then after that, I will say print f, just I will print the values of those two, x and y. So I will say here, for example, x equal, and then modular, okay, this is modular d, and then y equal, and then I will say modular d. Okay, and then I will put here x and y. Okay, so that's very simple software. So I pass x and y to the set value, and then I will print the value of x and y. So let's run and see this how this one is working. So here's it. X is equal 10 and y is equal 30. Okay, not change even after I call the function. But how about if this function, okay, do some operations on the variable and update the variable. Okay, and update the variables. We want to update the variables. Okay, so change the value of the variables. So that means I want to do some operation on X and some operation on Y, and then when I print X and Y, this function change the value of X of Y. So in this case, how I can do that? I need to pass X and Y by reference. So how? I will give the address of X, and then I will give the address of Y. I will give the address of X to this function, and then address of Y to this function, okay? And then these addresses will go here, and the address will be given to a pointer A. And then this address will be given to a pointer B, okay? So the pointer received the address. So now the pointer is pointing to X. So that means after that, whatever I do for A, this is dereferencing. Whatever I do for A and whatever I do in B will be changing what? The original X and Y, okay? So again, one more time, I will put the address of X here, the address of Y, we call this one pass by reference. Pass by reference, okay? Reference means address. So I pass the address of X, address of Y, and now the address will go to the pointer. So now the pointer is pointing to X directly. And then now the B pointer is pointing directly to Y. So whatever I do here, operation for updating the pointer, it will update the original value of X. Whatever I do for the pointer B, update of the value where the pointer is pointing to, it will update the value of the Y. So let's see, after we do this kind of a change here, we pass the address to the function, and the function have a pointers here. In this case, let's see what will be the value of X and what will be the value of Y. So let's see this one together. Oh, this is a change now. So that means set value function change the value of X and change the value of Y. Why? Because I am passing X and Y to the function as address, and now those pointer can do whatever they want to change the value of X and value of Y. I hope this one is clear. So this is one of the main important use of pointer. One of the main important use of the pointer is to control the original variable, and the original variables here inside a function. So control the original variables passed to the function. So you are not passing now copy of the function, copy of the variable. You are passing the original variable, and in this case, whatever happened here will change those variables. This is very, very important to understand. Okay, this is one of the most important use of pointer. Okay, pass by reference. You might ask, okay, professor, can we do this one without using pointer? The answer is a little bit tricky. So how this one will be tricky? I can here, for example, pass the value of A, okay, and then how I can do this same thing using, how I can do the same thing but don't use the pointer. Is it possible to do that without using the pointer? The answer is yes, you can do that. So for example, let's do this one without using the pointer and see how hard is it. Okay, so set value, and then I will set the value here, the first value, set value, and this one retains some integer, okay, and then this value will be A, and then this is the equation of A, okay, and now A is a copy of X. So X will come here, and then X will be retained here. So I'll say return A, okay? So here I am receiving one value, and then I retain value, the update, the new value will be retained back, okay? But the retain value back, okay, sorry, I need also the integer B here because it's required, okay? So it will pass two values, and it will calculate the value of A, the new value of A, and retain value here. And then this retain value, I will do it like this, okay? So, okay, by the way, I need to, so set value A, for example, okay? And then here I will say like this. Let's see how we can do this one without pointer. I will say here, for example, X is, the new value of X is equal set value A, and then I will pass X and I will pass Y. So so I will give x and y to this function. So x come here and y come here. And then the calculated of the value of x will be here. And this value will return back. Okay, it will return back as integer. And this return value will go to x, the new x. Okay, and now we can do the same thing for y. So for the y value. So I will copy here and then I will say set value and then this one b, for example. And this one receive two values, for example, and it will take this calculation. Okay, maybe this calculation does not need any a. So in this case, no need for a because there is no need for a here in the equation. So I retain b here. Okay, that's good. And now this is value of b will be here. Okay, so here's it. I said value of b. I will give this one just y value because it's only y required to calculate the new value of y. And then I will say this one is equal y. So in this case, this one will give me exactly the same result like this one. So let's comment this one and let's see if this one is working fine or not. Okay, so this one has x and y and retain y. Okay. Okay, so this one receive x and y. Let me just see if this one is correct. The name of the function. It was not correct. How about this function? Control C. It was not correct. So let's see. Run. Yeah, it works now. It was wrong variable function name. So let's see if this one is working fine. Yes, same result. You see, -5 and 75. You see how complicated? I need to create two functions to do that. Why two functions? Because the return value here, we are updating two values. Here in this one, we update A and we update B. But in the return value, only we can return one value. So in this case, I will update A in one function, and then I will update B in one function, and return the new value. Okay? So in this case, without pass by reference, without this one, I need to create multiple functions here. Okay? I hope this one is clear. Why do we need these pointers? Okay? So the pointers here are very important to do change multiple values one shot. Imagine we have like three variables here. If we have like, for example, three variables, for example, z here. In this case, we need three functions here. Okay, we need three functions. So this will save our time if we pass by address, and we use pointers here. Okay. And then whatever we do the dereferencing here to change the original value of where those pointer point to. Okay, so this is one of the main use of the pointer. So here's it. So this function here, set x and y, this is a pointer, and it will do some update for the x and y values, the values where this pointer point to. Okay, so I have here, for example, A and B. Okay, here is A and B, and then I set x and y. So I pass address of A and address of B. So address of A will go to the pointer. So pointer x now is point to the address of A, and pointer y is pointing to the address of B. Now whatever I change in the x and y, it will change to the original values of A and B. Okay, so this is, I hope this is very clear. Okay, now let's go to the a new thing is the how to deal with arrays and pointers. So arrays actually is a pointer. Okay, so the array name is a pointer. The pointer, and this pointer point to the address of the first element in the array. So when we have array, here is it. So I will draw here one array. So imagine we have an array A. This is array A. And this is element number 0. So this is array element number 0. And this one is A element number 1. And this one element number 2, and so on. Okay, so the name of the array is pointing to the address of the first element in the array. Okay, and I will prove this one for you now. Okay, and now usually when we pass array to a method, when we say, for example, I have integer array, for example, 5 elements array. Okay, so this element is 1, 2, 3, 4, 5. Okay, so this array is 5 elements, and then after that I say function. When I say function here, and then I pass the array to the function. Okay, so I say here array like this. In this case, you are passing the address of the array. Passing the address of the array, that means you are passing this one to a function, and that function receive a pointer of the array. Okay, pointer over the array. Okay, so this is, you have to know. Now, the address of the array is here. This is the address of the array. So let's see here, for example. Here, for example, when you say, for example, here, I have array, and then this array is array 10 elements, and this is array 5 elements. And then I pass here a function, I have a function foo, and then I pass the address of the array. When you pass the address of the array, in this case, in here inside, you cannot say, for example, here, you cannot say, you need to pass here the size of the array. The size of the array must be passed to, because here you are passing only the address of the array. When you pass the address of the array to the function, it doesn't know, the function does not know how many elements in this array. If you want to know how many elements in this array, you must pass another input parameter, and this input parameter or argument will be the size of the array. Here is it, the size of the array. So here you pass the address of the array and the size of the array. Why? Because this one is just the address of the array, and in this case the function does not know what is the size of the array. So you need to tell the function how many elements in this array. Okay, so here, for example, to prove that, let me just show you some example to prove that. So here, let's go to Visual Studio here, and then, okay, let me just delete this one so it will not be noisy. Okay, let me prove that the array, when you pass array to function, does not know what is the size of this function. What's the size of this array? So I have a function here, okay, and then this function receives some array, okay. So let's see here, it will receive integer array, okay, array, and size, okay, integer size of the array. Okay, so this is the function, and now this function, yeah, this is the function, and now here I will say print f, and I will say here, for example, okay, size of the array equal, so modulo d, some digits, size of the array, and then I will put here, I will call the function size of. We know the size of. Size of will tell me how much the size of one variable. And then I will go here, I say array. What's the size of this array? Okay, so this is very simple. Okay, and now here, I will back to this one later. So let me copy, but just copy this one. Okay, and I will say here, for example, I will design some array. I'll say array, okay, integer array 1. And this array 1 has 5 elements, okay, and all of these elements are integer. So when I say here size of array 1, okay, in this case it will tell me what is the size of this array, and then I will pass this array to a function. So I will say here, for example, function, and then I will say give this array to the function. So now the function is receiving the array, and then maybe the size of the array I can put here 5, for example. So here I am giving the array address of the array to here. So now this array is pointing to array 1. Now when I say array here, what is the size of this array? Okay, I can call this one array 1 so you will not be confused. It doesn't matter, okay? This is not, doesn't matter, okay? But just to let you here focus. So array 1 will go here, okay? And now let's see the size of the array here. So in the main function, when I define the array, when I say the size of the array, it will print for me, so before this one, so I will not run this one now, I will run only this one. So let's see what will be the size of the array. Okay, the size of the array equal, sorry, I did not say modulo D here. Okay, now let's run this one again one more time. Okay, here is it. The size of the array 20. Why 20? Because 5 times 4 bytes, it equals 20. So this is the size is equal to 20. Okay, so this one size equal to 20. Now let's run this one. So this one will print, okay, maybe I will put here modulo, just a new line. And the size now, it will print this one, and then it will run this function and print this one. Okay, so let's see what will be the size here in the function, inside the function. Okay, so look here, the size in the main function was 20, but the size of the array in the second one is just 4. Why 4? Because this one is not array, this is the address of the array. Address of the array is a pointer. Pointer point to address of integer. That means it's 4. Just pointer point to integer size. Okay, so this one just a pointer. This is a pointer. Okay, so this you must remember. This is a pointer. This is the address, and this is the address of the array. But the size is 4 here. That means it's just the address size. The address size. Okay. Now let's see. If I say here in this array, and then I will say here, like 1, 2. This is the element of the array. 3, 4, 5. Okay. Those are the elements of the array. Now, after that, let's just prove for you, this is a pointer. This one is a pointer. So I will do like this. I will say print f, and then I will say here, for example, first element, first, okay, that's fine, element equal, the first element, that means element number 0, okay? So the first element is equal modulo, okay, modulo D, so modulo D. So this one will be what? This one I can say like this, array, the address of this one, comma 0, okay, like this. So let's see this one, if it works or not. Okay, let's, oh, sorry, I put a new line here. Okay, new line. Okay, look here. The first element is 1. You see here? This is the first element. Or I can do like this. Or I can do like this. Star. Star. Star of this one. Star me because this one address. And this one is the pointer of this address. So let's see this one. It will be same or not? Yes, it's same. Oh, does that mean this one is like a pointer? Yes, it's address, and this is like a pointer, and you can use this one as a pointer. How about if I want to know the second element? Oh, that's very simple. I can do like this. I will between the brackets, and then I will say this point, this is the address, increase to this address just one location more. So one location, it will go to the second element of the pointer. So let's see this one together, if it works. Oh, yes, it works. Okay, how about, let's continue, 3. Yes, it worked. Okay, so this is element number 3. So element number 0, element number 1, element number 2, element number 3. Here is it, element number 3 is 4. Okay, so this one means this one is a pointer. You might ask, oh, okay. So is it possible to use the same expression here in the main function where is the array is used? And the answer is no. No, you cannot do that. You can use this expression when you pass the array to a function. Only when you pass the array to a function. How about if I use this one, the same thing for, okay, copy, and I will use the same magic here. So I will say here, same magic, and let me stop this one just for now to just say I want first element, and then I will say first element plus, okay, first element is this one. So let's see, this is the first element. Let's run. Yes, it works, okay, but let's do the operation like next element. Okay, the first element is fine, but how about next element? So I say 1 here. Yeah, it works. 3. It seems, yeah, it seems like it works in Visual Studio, but in some compiler it will not work, this one, okay? But anyway, this one here, just it sometimes it works and sometimes does work when you are defining it near the array itself. But if you pass this one in the function, it will work fine for all compilers. But in Visual Studio here, it works, but maybe in other compiler, like you are using another compiler, not Visual Studio, in this case you will have a problem here, okay? You cannot do that. So for example, let's try to increase. For example, I say here, for example, I say this is just printing. How about if I say here, okay, I will say the array now, I will change the update. The array address will now point to the array address, array1, update. The address now is starting from element number 1. Okay, it's going to the element, so the array starts from this one. Can we do that? So let's see if this one will work or not. Okay, and then after that, I will say array1. So let's see this one, if this one will work or not. So I will stop this one and let's see what will happen here. I will say array1, and now look here, array1 go here, and then array1, I change the address. The array1 was pointing to address number 0. The array1 before, if you see, just let me explain this one before I run. Before, the array1, it's like this, the array, and there was element number 0 contained value 1, and this is element number 1, 2, 3, 4, and 5. And now array1 is pointing to element number 0. Array1 is pointing to this location. But when I say +1, now the pointer of this array1 start not pointing here, it's pointing here. Okay, it's pointing to this location. It's not pointing to this location anymore, and now it will assume this point to this one. So if I say after that, for example, give me the value of the first element in the array. First element in the array, it will tell me 2. So let's see if this one is working. Yes, it will tell me element is 2. It's pointing to element number 2. Okay, it's the first element. I assume the first element is element number 2. Why? Because I update the pointer. I update the pointer here. I make the pointer start not pointing to the first element, go and point to the second element. So now this one is the first element now, became the first element. Okay? Now, can I do the same thing in the main function here? Let's see this one together. So I will stop this function and I will do the same behavior here. The same behavior. Okay? And it will tell you, no, you cannot do that. You cannot update the address of the array where you are defining the array. When you pass the array to a function, yes, you can update the address of the pointer to anywhere you want. But when you have an array directly here and you want to update the address of the array directly, it will tell you no. What this one mean? That mean the array address here is a constant pointer. The array address here is a constant. Constant means you cannot change the address. You cannot make it point to the second element. No way. Okay? So the pointer here of the array is a constant pointer. Constant pointer means this pointer only point to the first element and you cannot change the pointer to point to the next element. You cannot do that. But can I do that when I pass the array to another function? The answer is yes. You can do that if you pass the array to another function. I hope this one is very clear and important for you to understand. Okay, so here I already explained this one, and yeah, now okay, when you have array here, array A, and then you make the array, update the address of the array, it will show error. But if you if you give the address of the array to a pointer and then update the pointer, that's fine. Okay? Give the address of the array to another pointer and then update the pointer, that's fine. But update the array address directly, no way. You cannot update the array address directly. You cannot say A++. Okay? Why? Because array name here, array name is equivalent to constant pointer. You cannot change that. You cannot make array address go ++. You cannot do that. Okay? So you have to remember this one. Okay, now now how to access the elements of the array? You can access the element of the array using the array indexing, like this one here, or you can access the array elements using pointers, like this one. So this one and this code are exactly same, So here I create a pointer, and then I say the pointer is point to the address of the array, the first element in the array, because this one, the name of the array is the first element of the array, address of the first element in the array. And then I say if the pointer is less than the address of the last element in the array, address of the last element, you see address here? This is the address of the last element in the array, P++. That means increase the pointer every time and then print the pointer value. Okay, so let me do this one together with you so you will understand this one slowly. So here, okay, and let's just stop here, and then here's the function. I call the function, pass the elements of the function. I can loop and print all elements of the function like this. I say for loop, and then I will say here, okay, I can say, for example, integer I equals 0, from I equals 0. I can say integer I, and then I will say here I equals 0 to I less than the size, I++, okay? And then what I will do here, I will print elements of the array. So I will say print f, and print all elements of the array. So how to do that? I will say, for example, array element, and then I will say here element number, okay, I will just say modular D, just modular, very simple, modular D. I don't want to go in complicated things because I focus on the concept here, and say I'm modular D, and then I will say here array one, and then index I. Okay, so I will go one by one, and then after that maybe new lines. Just let's make a new line, and then just I call this function. Okay, so this function, it will run. So let's say run this one together and see how this one will work. You see, here is it, 1, 2, 3, 4, 5. Okay, all the elements of the array will go until the size 0, 1. So element number 0, element number 1, element number 2, element number 3. Can I do this one the same using pointer? The answer is yes, you can do that. So like, for example, from I equal array 1, this is the address of, and now I is a pointer. So I can say here I is a pointer, and then I is pointing to the address of the array. And then from I less than the address of the last element in the array. So the last element of the array will be like this. The last element in the array will be for I less than the last address of the last element in the array. Last element is the element number size, okay? This is the last element in the array. And then every time I increase. So first time I is pointing to the first element in the array. Next I is equal the second element in the array. And then +1, it will be the third element in the array. +1, it will be the fourth element in the array. So every time print. And then I will see here what? Just to print the value of the pointer. Where is the value this pointer is pointing to? So where is this pointer pointing? So this is, we'll do the same thing. So let's see if this one is doing the same thing or not. Exactly same thing, okay? So this one, you can do it same way, like, so both of them are fine. So you can use the pointer concept, or you can use the array indexing of a concept. Okay, so here is I is point to the first address of the array. I is a pointer, point to the first element in the array, and then I go every time until the last element in the array, the address of the last element in the array. Every time the pointer go one step, the pointer go one step, one step, one step. And every time the pointer go one step, I print the value of the pointer, the value where the pointer is pointing to. Okay, so this will be the value of the element in the array. Okay, so this is how you can use the pointer for looping in the array. Okay, so here array and parameters. So this is just several way to pass array to a function. Look here, just before I go to this one, let me just go back here and update this one. So here, if you see this one, I told you this one is the address. Okay, this is address. Okay, can I put this address as this address? I can replace this one by this one, like this. Just be careful. Look here, star and like this. Is it same? Yes, exact same. Because this one is address. So this address, when you say address, this address go to this pointer. This address go to this pointer, and then now go step by step for this one. So let's see if the results are same. Yes, the results are same. Everything is same. So you can put this format, like the address go to the pointer, or just keep the original format. This is array, but this is a pointer. This is a pointer. Okay, so this, because I told you this is a constant pointer, constant point. So this constant point will come here, and this one will do here. Okay, so this way or this way, it's up to you. Okay, and this is what I show in the PPT file here. So I show here, you can create the array. You can, in the function, this is a function point, you can pass the array this way, and this is the size of the array. Or you can pass the array this way, and then you create some pointer inside, and then use the pointer to access the element of the array. Or you can make this one as a pointer, and then give pointer inside equal to this pointer. Or you create this one as a pointer, and then you say I, and then every time you will, from I equal 0 to I less than n, okay, n is the size of the array, increase I, and at the same time increase the pointer address. And every time just print the value of that pointer, because you are increasing the pointer. So the first loop, the pointer point to element number 0. Next loop, the pointer point to element number 1, element number 2, element number 3, and so on. So this way is okay, this way is okay, this way is okay, and this way is okay. It's up to you. And all of them are doing the same results. All of them are printing the elements of the array. You can check this one by yourself later. Okay. Now, yeah, this is for arithmetic of the array, and we already talked about the arithmetics. So when you say, when you are saying here, whatever the data type here, whatever, this one is integer, this is a float, this is double, this is whatever this data type, when you create a pointer, so if the array is type t, like whatever this t, I'm saying t here mean any type of t, integer, float, double, any type of array. In this case, if you want to create a pointer to point to the address of the first element in the array, the pointer must have the same type like the array type. Okay, this is what I want to say here. Okay, and then in this case you say, okay, the pointer will point to the address of element number I in the array, and then you can do plus plus as you want for the pointer. Okay, so also you can do addition, subtraction. So when you say, for example, pointer plus n, when you say n here, this n means how many elements you want to jump, how many elements, okay, not how many bytes, how many elements, how many elements of, so how many bytes every time you jump, it's equal n. For example, if n is 5, it will be how many bytes you will jump, 5 elements, and each element, what is the type of size of t? Size of t, for example, if t is integer, so it will jump 5 elements, and each element will be 4 bytes. That means it will jump, the pointer will jump 20 bytes in the address. Okay, so this and here mean how many elements you will jump, not how many bytes, how many elements you want to jump. Element of what? Element of this data type. Okay, whatever this data type. T could be integer, could be double, could be float, could be anything. Okay, so you can, for the pointer arithmetics, you can do comparison between two pointers, you can do subtract of pointers, you can do addition to the pointer, and we saw all of this one. So you can compare pointers, you can do anything you would like. So for example here, let's see this example, compare two arrays. So we have array 1 and array 2. So here is two arrays, okay, array 1 and array 2, okay? And this is the size of array 1 and this is the size of array 2. Okay, you pass two array here. And then you say here, I want to compare these two arrays. If size 1 is not equal to the size 2, in this case, I would say these two arrays are not equal. So it will return false. These arrays are not equal. If the size is equal, then in this case, I will do this comparison. I will say integer I equals 0 to integer I less than the size of 1, because both of them have the same size. In this case, I will compare array 1 address is equal to array 2 address. That means they are the same array. Something like this. So for example, I can call this function, I say like this, compare. Okay, compare. I call this function like this, compare arrays. And then I will pass like this. For example, I have array 1 and I have array 2. So I will pass like this, array 1, and then size of array 1 would be 3, and then array 1 again, array 1 again. So I am passing the same array, and then size 3. So I am passing exactly the same array. So if you pass the same array, that means I compare the address of the first element is equal to the address of the second element. So the second array elements. So if the address of this one is the same like the address of this one, that means I am passing the same array. I am passing here the same array, and in this case return true. That means these arrays are equal, are same array. But if they are not the same array, in this case I need to check the contents of this array. So I will do like this. I will say else if the elements of the array 1 at location I is not equal to the value of array 2 at location I. If they are not equal, then return false. But if they are equal, in this case, it will return true. Okay, so let's see how this one is working. So I will copy this code. Okay, so I will copy this code and show you how this code is working. So first of all, you need to use, be careful, you need to use bool here. Don't forget about boolean. For this one, for bool, okay? This is very important for this one, for the boolean. Where is it? Oh, I did not copy, okay. Okay, here we go. So here is the bool, so you need to use std bool, okay? Because you're using boolean. And now this array will, so for example, I create array number 1, and it's equal 1 to 3. And by the way, this is optional if you define the number of elements here. So I know this is a 3, so no need to put the 3 here, optional. It's up to you. But if you don't have this kind of thing, initialization list, in this case, you must put the size, okay? So I can put here, it's optional. And this one 3, it's okay. It's okay, it's optional, okay? Then after that, this is element number 3, okay? This is, so I have 3 arrays, okay? I have 3 arrays here. And now, I will do like this. I will say compare array 1 with array 1. They are the same array. So in this case, it will return for me what? True. True mean 1. It will return for me 1. So why 1? 1 mean true. Okay, so, and here compare array 1 with array 2. Array 1 and array 2 are exactly same values. Not same location, but the same value. So 1 to 3, 1 to 3. So that means this one also will return for me true, or it will return for me 1. So this one will retain 1, and this one will retain 1. How about this one? Compare array 3 and then here array 1, okay, and then array 3. Array 3 is different. So it will compare this element with this element are the same. This element with this element not same. Not same, that means it will retain false. It will retain false, okay? And in this case, this one will retain 0, mean false, okay? So let's see if this one is correct or 110. It will retain 110. So let's see. Yes, 110, okay? So this is this comparison function. So in this comparison, I'm using the array as a pointer. So here is the address of this one with the address of this one. Every time the I increasing, I will be 1. So element number 1 with element, so first time it will be 0. So element number 0 with the address of element number 0. Are they same? Yes, same. Element number 1, array address number 1, element number 1, and the address of element number 1 here are same? Yes, same. And then address of element number 2 is equal to the address of element number 2? Yes. In this case, it will return true. This is in the case of this one and this one are same. In the case of array 1 and array 2 are different. In this case, this one will run. Okay? And this one will compare. Array, the value of the first element is not equal to the second element? No. Then in this case, go to the next element. Is it this one not equal to this one? No. Then in this case, go to the third one. Is this value of the third element is equal to this one and the third element? No. So in this case, it will jump and return true. The last one, array 1 and array 3. Array 1 and 3 will run here also. So array 1, element number 0 is equal to array 3, element number 0? Yes. This one and this one are same. And then element number 1 value is equal to element number 1 value here? No, they are different. So in this case, it will retain false. So this one will retain false. Okay, so I hope this is clear here. Okay, so by the end, that's it. This is the end of the pointer topic. We will see this topic of the pointer several times later during the classes. And the most, just I want to say here, the most important thing about pointer is that you can pass the pointers as a reference or pass by reference. You can pass the variables, pass the address of the variable to a function, and then use the change on the variable, original variables using the pointer inside the function. Okay, and then also we saw today how we can use the array as a pointer. We said the address of the array is a pointer, constant pointer, and then when we pass the array name to the function, that means you are passing a pointer to the function. And in this case, whatever the function do over the array will be reflected to the original array. Why? Because you are passing the original array. Whatever you change in the array will be changed in the original array. Okay, so that's it for this lecture. Hopefully this one is clear, and we will practice this week for this topic. We will have one assignment to practice this one, and if you have any question regarding the pointer, please put the question in the discussion section, and we will be happy to answer your question regarding the pointer. The pointer, if you master this pointer, that means you are capable of controlling the memory of the computer, because pointers can point to any place in the memory. So if you control the pointer address and you know where is the pointer is pointing in the array, in the memory, in this case you can control to read any place in the memory as you want. Okay, so for example here, just let me show you just example about how powerful is this pointer. So let me just show here. So I can say, for example here, integer, and then this is a pointer, and this pointer, so for example I have integer a and equal 5, so this a is in some location in the memory, and then I would say this pointer is pointing to the address of the array, or address of a, sorry. Okay, and then after that what I can do, So I can make a loop, for example, for loop, and let me just show you this one. It's very powerful actually. So integer I equals 0, and then I will make a loop to read from address of A to like 100 location in the memory. I will read the content. So I will do like this. I will say I equal 0 to I less than 100. And then I will say I plus plus, okay? What I will do here, let's see what I will do. I will say here print f, and then I will do here, okay, modular d, that means print some d, and then a new line, and this d will be what? This d will be the value of the pointer. So the pointer, where is the value of this pointer? Where this pointer is pointing to. And then, but I will say every time, increase the pointer by I. So every time the pointer go to the next element, okay? So this one will jump 100i. So it will go 100i. So that means it will print from your computer memory 100 locations values. So let me show you this one. Okay, look here. So at the beginning, A was 5. So it will print 5. Then this one is from your computer memory. This one is values inside your computer memory. Look here. So there are some values garbage and some values are meaningful, like those numbers. So those are, I can read, look here. This memory location here became empty. This is empty location. There is some garbage here, and then there is empty, and there is garbage, and so on. So you can read the computer memory using the pointer. Why? Because you are just looping, not only read the pointer, you are reading after the pointer. So you read next integer, next integer, next integer. So you are reading the whole memory using the pointer. So pointer is very powerful, and you can use it to access many locations in the memory, even it's belong to variable or it belong to something else. And we will see this one maybe later when we try to study more about pointers and how useful this trick is. Okay, so that's it for today. Thank you, and we'll see you next week.